So, okay, I think we can start. Before I'm on the stage, my friends told me today is the magic day because today is March 14, so it's Pi Day. So it's really memorable, and we think we can share some interesting things for you. Okay, so the title, we want to reduce the TCO and accelerate the adoptions, OCP adoptions by the open technology from Inspur. So first of all, we've seen two different direction. So from the left-hand side, you can see that currently the smart devices. This is one report from HIS. The more and more devices should be connected to the IT data center, so that can be managed. So we can see this is a kind of increasing customer demand to the IT infrastructure. On the other hand, the CIO, they have a very limited budget. So you can see from the right-hand side, the IT expanding is really a keep flight. So that's a dilemma for the CIO or for the data center operators. They need to satisfy more and more customer demand for the management devices, and they have a limited budget. So how to mitigate the TCO in the data center? Well, they can serve more customer demand. So this is the challenge for them. And we think we have three key points. As we have already serving the customers, IT customers over decades, we have some reference value from the engagement with hyperscale data center customers in China. So the first point as the joint design model. This is joint design model is we actively engage with the customers. They give us their spec, a kind of customer requirement, but we do not only follow their spec, design the system. We interactively discuss how we can improve their design. And then when we get the reach agreement, we physically design the system and we manufacture for them. Finally, we deliver the system into their data center. So we call it a joint design model. So through this kind of, we call it a severe test, we delivered a very huge amount of server units to the Ali, Baidu, and Tencent in the hypergiant, CSP giant in China. So we have got the approved supply chains, also the server quantity. So that's one value from the JDM model. Secondly, we have, as I said, we have served our customers over decades. So we have rich experience, and you can see from the in the middle that we have several different function nodes, server nodes, storage nodes, and the currently very popular AI GPU node. So beyond of that, we also provide some of the rack management, also the pooling technology, so combined together. So this is the second. We have rich design experience. Last but not least, as this open community, we contribute our designs to the OCP, so that the customers, 2 points. One, the adopters, they can pick up the designs. Because we open the design files, so the customers, the adopters, they can save their design energy and implement the design easily. So this is one value for the adopters. Secondly, for the end users, they can pick up from several adopters, so they cannot be locked by a single vendor, single choice. So these are two key values from our contribution. Also, I think this is the promotion point by the OCP community. So I will, in the next several pages, we will talking about the portfolio or the designs we contribute to the community. So this page, we're talking about the server nodes. There are two different categories, the server nodes we provide. So from the left-hand side, you can see that this is two socket designs. We have one primary design is we call it the energy efficiency. We already accepted. It's OCP accepted. It's a two-socket design, and we have the two full-height half-length PCIe slot, and the M.2 and the hard drive options. So this is one primary design. The derivatives from this design, we have the I/O balance design. So the PCIe slot will be routed from the two different processors separately. So this is I/O balance. Also, we have the high expansion. So we will route more PCIe slot and more M.2 hard drives from the processors. And also, we have the density. So there will be one OU designs. So we can accommodate more server nodes into the rack. So these are the two socket designs. On the right-hand side, we can see we contribute the full socket designs to the OCP community. So the first design is a jointly design with the Microsoft Olympus project. So it's a full socket design. Also, we have the 9 full height half-length PCIe slot, and also have the 5 M.2 SSD, and also the hard drive. So this is kind of suitable for the enterprise customers' needs. Although OCP is kind of for the data center customers, we think the full socket is a nice try for the open designs, because we haven't seen any full socket designs in the community yet. So this is the first one we contribute as the full socket options. Secondly, we call the code name is Crane Mountain. This is one cloud optimized full socket. For the cloud optimized, because we for one 42U height rack, with the 2U full socket design, we can deliver 80 processors. And also, we have saving the number of fans, and also the power consumption by the whole system, because we have a less number of the server units versus the two-socket system. If we deliver 80 processors at the same time, the two-socket system will be 80 nodes, right? But with the full socket, we will only have 20 nodes. So the power consumption will be saving, and the fans will be saving. So that means the power consumption and the TCO will be mitigated. So this is a very key value for the hyperscale data center operators, because they will provide the virtual machines to the end users. If they deliver the same amount of virtual machines with the less power, they will save the money for their operations. So this is the key value from this the cloud optimized full socket design. So we will, excuse me, we will open these designs to the OCP very soon. And secondly, this about the AI nodes. Currently, the AI or the deep learning, machine learning is really become more and more popular in the community. So we have I call this, the trend. We have two designs. The first one from left-hand side is 3 OU, 8 GPU with the NVLink. So this is the first one. Secondly, we have the 4 OU, 16 PCIe GPU adapters, two designs. And these two designs has two different switching topology. So we can meet different customer needs with the GPU nodes. So this is the physical contribution. And this is we also do some comparison in our lab. So this comparison between the full socket Olympus connecting the 16 GPU nodes versus two socket host connecting with the 16 same amount of the GPU. The performance is running the CNDK is one of the Microsoft framework at position of FP32. So the performance you can see from here is the green bar is the full socket host delivered. The blue bar is the two sockets host delivered. So the more processor means the more memory data set prefetched at one time. And also, that means the more GPU adapters connecting with the system. So that's why, for CNDK, it's kind of delivered by the large data set. So with the full socket system, so we think the full socket system will deliver more performance or has the faster low latency with the visual recognition workload. So that's the key point. And so this one is the OCP storage node. So actually, this design is coming, or we refer to the smart rack, one of the joint design together with Inspur and Baidu. So we have some modification on the designs. Finally, we have the 2 OU and deliver 34 pieces of hard drives from the 2 OU high chassis. And the capacity is 13% more versus the same height node currently in the OCP community. And also, this is the front access tree, so that the customer or the data center operator, they can easily to access the trays and to replace the hard drives. And this is the toolless designs. For example, if one hard drive will fail, the IT operator, they can just pull out the tray and replace with a new one. They don't need the screw to replace the hard drive physically. So it's easy to maintain. And also, we optimize the chassis. So we share the funds and the power with the other, the chassis, so that we will saving the cost for the whole data center. And this is this is the whole picture of the OCP server node and the AI and the storage node we are currently delivered in the IT community. So shortly to say, we have very kind of a relatively rich portfolio on the OCP community, and we through the JDM model, we can jointly design the node, not only this one, maybe if customer, they have their unique requirement, we can jointly design the spec, and we can contribute to the OCP, so that the customer, they can pick up from the different vendors at the same designs, so they can have their best choices. And So last but not least, I think you can visit our booth from the expo hall. And also you can visit our website, www.inspursystems.com. So you can have more details about our systems, not only the OCP. Okay, thank you for your time.